For this lesson, we're going to step away from our design process for a second to take a quick look at mechanics and mobility. A key part of designing a mech is the fact that it is a moving vehicle, which means that its mechanics and its mobility is going to have to be a core consideration while we are doing our design. This lesson, we will do a couple of exercises to take a look at how to best approach mechanical design. Our mechanical considerations are going to fall into three main categories, which is rotation, clearance, and stress. We're going to start by focusing on rotation. Let's start by taking a limb, for example an arm, and simplifying it. In isolation, you can see it as two shapes that will be connected with a joint. This joint is where movement will have to happen. The simplest kind of joint that you can start with is a one-way rotation. This means that it will be allowed to rotate in just one axis. Starting with the simple joint, let's talk about some of the key considerations you would have to have designing a joint. One of the first is that you have to have an axis of rotation. In the small drawing, you can see that the cylinder is representing the central point where the rotation would happen. And you'll have to think about how the joint would interlock and connect to the two different parts that have to move. Here below are a few examples of a single rotation joint using these principles. I would highly recommend looking up some references to gain inspiration. It's recommended to look at some simple joint references to kind of get the overall ideas instead of looking at overly complicated references. Things like simple door hinges or simple levers are the best place to look at first. Trying to copy complicated references has the risk that you will get so lost in trying to copy the complexities that you will not actually understand how it works. And the first thing you want to strive for when you want to gain the ability to do mechanical design is the ability to understand how something operates. Now, to further the complexity of that kind of rotation, most limbs will have to be able to rotate on more than one axis at the same time. If you think of your own legs or your own arms, you realize that there's a lot greater range of mobility that you have than just one simple motion. So your mech will almost undoubtedly have to take that into account. So expanding on this, we're going to go into two-axis rotation now. There's two main ways we can think about two-axis rotation. One of them is that we can have two joints in succession that will allow it to have that range of motion, meaning two one-axis joints that connect together, or we try and design a joint that can do both points of rotation at the same time. Here's a few examples of how to potentially solve these things. With this logic, you should be able to then take some of the different ranges of mobility and try and test out how to be able to make them work. The second point has to be discussed when you're designing mobility is clearance. Now, clearance is a simple idea that your shapes, which are connected with a joint, will have to be able to stretch out and collapse efficiently. It is very easy when you are designing a still image or doing a drawing to not realize that things can potentially get in each other's way. So when you take, for example, a leg, here in this example, you can see that in this example, it looks fine as a still drawing, but as soon as it moves, you realize that some of the design elements are actually intersecting with the others. So it's good when you are doing a design to mentally imagine how these things might move, or to even make a separate drawing just to see whether or not these shapes can actually fit together. So then as soon as you see that, you can see that there are certain spaces you will have to start cutting out, or will have to expand a bit to make sure that they actually fit within the constraints. When thinking of clearance, it will also reveal a couple of other things that you might think about. You would be tempted to just have the arm connected with a single joint. However, you realize that this can actually create a lot of clearance issues when you're trying to make a mech move. So possible solutions, for example, is to then do a double joint there, which allows for a bit of extra space to allow the two different parts of the arm to actually efficiently move and fully collapse without intersecting each other. The final consideration that we're going to look at for mechanical design is stress. Now, this is very simply that if you have moving objects and if you have all this mobility, weight is being pushed down on parts. This means that certain joints, in a realistic sense, would only have a certain amount of stress and weight that they could potentially pull. One is that a joint might be too small or might just have too much attached to it. If you, for example, have a massive claw arm attached to your arm, but you only have a very small little joint holding it up, this is not going to look realistic. Trying to hold that up and actually lift the arm would either jam the joint so that it just could not generate enough power to move it, or it would potentially just fall down and break the joint. With legs especially, this is something that you're going to have to think about. The mech is a very weighty object by itself, and it has to stand on its legs. If its legs don't feel like it can bear the weight, then you're going to essentially run into the issue that in the real life scenario, your mech would almost instantly collapse and break if it would try to do anything, or maybe even would break as it's trying to stand still. So to try and kind of address this, you want to look at designs and you want to kind of think of how the stress would impact some of these limbs. Two big different ways that you can try and reduce stress on parts is to either make bulkier, stronger joints that would be able to support more weight, or to have support structures to distribute weight. This would be things like hydraulics or support struts that would allow the weight not to have to all go down to the joint or go nowhere, but could potentially add extra support. As a task for this lesson, we're going to do a couple of exercises based on all the points raised. The first I would like you to do is I would like you to look at some references and do a series of joints trying to solve both single and double axis rotations. I would advise to start with the single axis rotations to start getting acquainted with some of the principles, and then moving on to two axis rotation as you get more comfortable. The second exercise I would like you to do is to, as shown in the example here on the right, create a few dots and lines that represent the skeletal arrangement of a limb. This can be a leg or an arm, depending on what you want to try. And to then fill them in, taking into account all the notes about the clearances, the stress that joints would be under, and the ability for it to move. In these examples, you don't need to go too far in exactly how many axes of rotation have to be in the joints. I would prioritize trying to have a logical arrangement and logic mobility just in the 2D plane for these for now.